Hello everyone, welcome back to the channel. I am Nikhil Kumar. In my last video, I gave a high-level overview of the containers and the Kubernetes and why the Kubernetes is needed. Today, we will build on that particular topic and we will first deploy an application using Docker, then analyze its limitation, and finally see how Kubernetes solve these problems seamlessly. So, have you ever deployed an application using Docker? It's fast and efficient, but have you ever faced a situation where your container crashed? What if your application goes down in production? Who will restart it? Who will monitor it? That's where Kubernetes comes into play. So let's start by running an application using Docker. I will deploy a simple web application using an NGINX image. So for that, I'm going to use a command docker run -d -name and the name of the container, that is my web. I'm going to use a port that is 8080 and which will be bound to the port 80 of the container and the image name. First, it will try to pull an image from the Docker hub and then it will spin up a container from it. Now we can see the container got created. We can verify it using the docker ps command. We can see that the my web container is running. Let's try to see if it is accessible from our localhost or not. We can see our application is accessible. Now let's see what happens if the container crashes. So let me stop the container, docker stop my web. I'm intentionally doing that, but if some issues happen on the host machine or the container side, so that particular application will crash, right? So the container got stopped, and if we run this particular command again, now container is not in the running state. The container is stopped. Let's run the curl command again. As we can see, our application is not accessible and Docker doesn't automatically restart it. If this happens in production, user will face a downtime. We can restart it manually using the docker start myweb command, docker start and myweb. It will start the container again and we can see our container is in the running state. And if we try to do the curl again, we can see our application is accessible. But this is not a reliable solution. We need something smarter, something that can handle failures on its own. And that's exactly what Kubernetes does. So let's see it in the action. For this setup, I'm going to install a single node Kubernetes cluster using the RKE2. It will act as a both master and the worker node. So first of all, let me run the script which will be installing the RKE2 packages. RKE2 single node cluster will be very helpful in our learning journey. I would suggest you to use the RKE2 for your learning purpose, because in this you don't need a high-end computer or the system. You can do it on your GCP or AWS instance as well. Now let's enable the service and start the service as well. It will take 1 or 2 minutes to start the service, and then our cluster is up and running. Service got started. Let's verify it. Systemctl status. Our Kubernetes service is running, that is our RKE2 service. And let me set a path for the same so that we can access the binaries of the RKE2, that is kubectl and the ctl, which will be needed to manage the Kubernetes resources. And let's verify. kubectl get node is the command to see the node information. As of now, I won't be able to access the Kubernetes cluster because I need to set the kubeconfig path. So to do that, we can use the export command with the kubeconfig and the path of the Kubernetes configuration file. Don't worry, I will cover these topics in very much detail in my upcoming videos. So I am going to set a Kubernetes configuration file. And if I run the same command again, now I can see the Kubernetes cluster is up and running and it's in the ready state and it's been deployed 104 seconds ago. Now let's deploy the same web application, but this time using the Kubernetes. I have used the kubectl command to get the node information. So kubectl is the command line utility to interact with Kubernetes, similar to how we use for the containers, that is Docker. Now let's create a container. So in the Kubernetes, we can use the kubectl run myweb1 and the image name, that is our NGINX. So the pod got created So let's verify that. So to verify, we have a command kubectl get pod, and we can see that our web app is running. But what happens if the pod is deleted? So let's try it. So if I manually delete the command just like we did in the Docker, kubectl delete pod and the my web app 1, the pod got deleted, and let's verify the same. So there is no resource with the name called myweb as of now. So unlike Docker, this pod is now deleted, but Kubernetes has a solution for this, that is deployments. So let's see how it works. So instead of creating a pod, we will create a deployment. So to do that, I will be using the same command, but instead of run, I am going to use a create deployment and the deployment name and the image name, and the deployment got created, and if we see, the pod also got created with the my web app. And now let's try to delete it now. So kubectl delete pod and the pod name, and the pod is getting deleted, and if we run the kubectl get pod command again, we can see the new pod got created again with a different name. Earlier it was having n2f and some random character at the end, and here the new pod got created. This is the magic. Kubernetes maintain the desired state and ensure the application is always running. Now let's describe this pod and see the information about this thing. So kubectl describe pod. So it will give a complete set of information about this particular pod. Don't worry, I am going to cover pods deployment in very much detail in my upcoming videos. Now let's expose this pod so that it can be accessed externally. In the Kubernetes, we use the -p parameter, that is to do the port binding. In the Kubernetes, I'm going to create a service resource. So for that, I am going to use a command kubectl expose deployment and my web app. So first let me verify the deployment name, that is my web app 1, and let's push the same name here, web 1, and the type is NodePort, and I'm going to use a port that is 80. Let's see if the service got created. Service got created and it got binded to the port number this, but I mistakenly created it to the port 70. Let me delete this one and recreate it. kubectl delete service, and let me verify it got deleted, and let's create a new one with the port 80 because our NGINX application will be running on the port number 80. Now let's verify the same again. We can see the port got updated and it got bound to the 32204. Now let's try to access this application on port number which is given by the Kubernetes, that is 32204. And we can see our web application is accessible. Now, no matter what happened to our pod, as long as the service is running, user can access our application without worrying about the pod restart or IP changes. This is how Kubernetes service provides stable networking. Now imagine our web application is getting a lot of traffic and one pod may not be enough to handle all the requests efficiently. We need multiple instances running at the same time. Instead of manually running multiple containers like in Docker and Kubernetes, let's scale effortlessly. Let's scale our deployment to 3 replicas, meaning Kubernetes will maintain 3 running instances of our application. So to scale our application, we can use a command kubectl scale deployment my web 1 and the replicas to 3. Now our application got scale, and if we see the kubectl get pod command, we can see now the 3 pod got created. Earlier it was 1, now we have a total 3 pods. Now Kubernetes automatically distribute incoming requests across these nodes, improving performance, fault tolerance, and if one pod fails, Kubernetes ensure another one replaces it. So let's try to delete this one. Kubectl delete pod. As soon as I delete this, Kubernetes will create another pod. So we can see the new pod got created, that is 5 seconds ago. Basically, Kubernetes immediately created a new one to maintain a desired count of the 3. That's what we have set up in our deployment. This is what makes Kubernetes a powerful orchestrator. Scaling down is also an easy task. If we want to reduce the number of pods, we just need to run a command, that is kubectl scale deployment, that is myweb1 and hyphen replicas equal to 1. As soon as it does this thing, so Kubernetes will delete 2 pods and stay with the 1 pod. And just like that, Kubernetes reduces the number of instances to match our requirement. This is dynamic scalability, ensures we only use the resources we need, making application efficient and cost efficient. In this video, we have learned how to deploy an application using Docker and Kubernetes and understood Kubernetes advantages and saw how deployment and the service work. So if you found this helpful, don't forget to like, subscribe and hit the bell icon so you don't miss any upcoming videos on the Kubernetes series. So see you in the next one.